verify the identity by transforming the left-hand side into the right-hand side. So my identity is that the sine of theta plus the cosine of theta all divided by the cosine of theta is equal to 1 plus the tangent of theta. So since I'm supposed to transform the left-hand side into the right-hand side, I will start with the left-hand side. My proof will proceed as follows. I'll say that sine of theta plus the cosine of theta divided by the cosine of theta is equal to, now I'm trying to think of how I can transform this. One common trick is to break apart a numerator that has a sum into the sum of two numerators with the same denominator. Specifically, then I can write sine of theta divided by the cosine of theta plus the cosine of theta divided by the cosine of theta. That's really just the rule for adding fractions applied in reverse. Right? These have the same denominator. I could recombine them into one numerator if I liked. It's more useful in this case to go the other way, to break up that fraction, because, and this is just, if I'm justifying my work, I should just note that I've broken apart a fraction. Using algebra. Now, I have the sine of theta divided by the cosine of theta. By definition, or rather by one of our common identities, that's simply equal to the tangent of theta. And the cosine of theta divided by itself will always produce 1. So what I've used there are the identity for tangent of theta and division of x over x equals 1 for any x, right? Any fraction where you have the same numerator and denominator simplifies to 1. And that actually finishes my proof. It didn't take long and didn't take very many steps. We're just simply rewriting the fraction as a sum of two separate fractions and using the fundamental identity for tangent popped out the right-hand side. So there's the end of my proof. I have transformed the left-hand side into the right-hand side of the identity, and therefore proven the identity.